So I just want to let you know that you can use the chat anytime you need to ask anything you want to Attila. So without further ado, I'll stop talking and let you have your talk, Attila. Thanks everyone for listening to me, and yeah, Attila, it's all you.
Okay, thanks a lot. And okay, hello everyone. I just need to mute the tab. Yeah. So hi everyone, and okay, after this nice talk from Anna about how TypeScript can help our life, and actually relate 100% with that, I'm now here to talk to you about how multi-threading can actually help you achieve a great user experience. Before jumping into the talk, I already tried to share something on the chat, but I'll just do it again now. I'm not sure if you got it. If you want to follow the slides on a separate window, you can do that with that link I just passed. And yeah, that's it. And when I'm passed, you're going to be going as well. So yeah, let's get started. So first of all, my name is Atila, and I'm here from Berlin right now, talking to you all. I work as a lead web developer at SAP. If you want to know a little bit more about me, there's my website over there, atila.io, and I'm going to be sharing some stuff on Twitter. Feel free to mention me there if you want to talk about something else. And also I'm going to be posting the slides there and everything. So if after the talk you have something to chat about this or about other stuff, React, feel free. I'm always up for it. And yeah, and as mentioned, I'm having my eye on the chat, so it's cool. So if you're like somewhere else besides Berlin, let me know on the chat. I'm always happy to know about it. And let's jump to it. So before we get started about how multi-thread is going to help our lives and how to get it done on a React app, I just want to clear something that eventually when we talk about multi-threading, we immediately think about parallelism and how that actually, and we try to have those concepts intertwined in our heads, but it's not necessarily so. They're not always together. So multi-thread, as one can assume, it's actually an opposite to single thread, whereas in single thread you have only one thread, and in multi-thread you have more than one. And parallelism is actually the opposite of concurrency. So we can have multiple threads that are concurrent, and we can have multiple threads that are parallel. And to make that more clear, to clear out the concept about how does that actually work, I would like to make the analogy of a chat app. So let's think, for example, Discord or Slack, where probably most of you are familiar with. We have the idea of multiple threads in chats, and that's basically very similar to what multiple threads in programming as well. So in the sense that you cannot reply to more than one thread, and you cannot read more than one thread at the same time. If you look at this window, for example, like from the Discord webpage, you have the study group thread, and you have the pet photos thread, and the games thread. And while you're reading one, you cannot actually read the other one. You're completely oblivious to what's happening there. So even if you're a person that is like really, really good at switching context, you're still giving attention to one task at a time. And that's basically how our engine works when dealing with multiple threads. We have those little tasks, then the engine is actually very efficient into jumping from one task to the other. So that's what happens when we have concurrent tasks, threads. In this case, each thread is competing or concurring for attention, which in our case is attention, in the engine case is processing. And what parallel threads is, and I think the best analogy that I could find for it is the one person band. So in this case, every musical instrument is a different thread, and they are all happening at the same time. While this person here is playing the accordion, they're also playing the keyboard, and they're also playing the trumpet and whatever else they're playing there. And they are all happening at the same time. So the resources are actually shared, and they're aware of everything that's happening at the same time. And what I'm trying to get at is that parallelism is actually a special kind of asynchronous programming. And that's what we're actually going to be talking more about in this talk, is how to get asynchronous programming to actually work with parallel threads. And so this conceptual talk is great, and we needed to get the baseline of the gist of what we're about to talk. But now we need to talk about what does it mean actually to JavaScript. Let's cross some T's and dot some I's on it. Let's have a look about our JavaScript APIs. And to get started, these are a list of asynchronous APIs that we have in JavaScript, and they are all concurrent APIs. So the first ones that we have seen, if you're old enough as me, are set timeout and set interval, as well as a XML HTTP request. And those are essentially, they're asynchronous, but they're in multi-thread, but they're actually concurrent. One good example about it is that set timeout doesn't really obey to the time interval you set to it, because if you have a long task being executed between the callbacks of a set timeout, the interval is actually going to probably be longer. Or if you have another task happening, it's not reliable. You cannot rely that time is the one that's going to be obeyed. Whereas that's the difference between set timeout and set interval, where set interval, you can rely on the time that you set, on the interval that you specify, but on the expense that it's just going to come crushing in and blocking whatever task is running at the time. And then you have promise, fetch, and async await, which are basically very similar APIs. They're all asynchronous, but they still happen in a concurrent way. And we're going to see a little bit more on that on our example soon. So what about then parallel? How can we actually get parallel threads in JavaScript? And there's more than one single way to do that. But what I'm here to talk to you about today is web workers. And this is the first time that it's showing up on the slides. There's that little link over there. And I'm going to share the slides later, and they're all clickable links. But don't worry, writing them down. The slides are going to be available soon. And that's just a link to the specification. So web workers are a way to specify a separate thread to our main thread, and basically creating this background thread where we can execute namely like very long tasks or tasks that could be potentially disrupting to our main thread on a separate environment. And yeah, that's what web workers are about. And that's why I like to say that UX and web workers walk hand in hand. Web workers is an excellent performance feature, but it prevents the UI of getting tasks that interfere with it, in the sense that we don't get blocking scripts anymore, because the web workers, they're running on a separate thread, and that's why we can have a highly responsive UI while the web workers are executing. And getting closer to what web workers are, we have two types of web workers according to the spec of them. And we have the dedicated worker and the shared worker. And they're very similar. Usually when we talk about web workers, we kind of mean both of them, but they have some important differences. First of all, well, the dedicated worker is dedicated to one main script, one main window. It's executed on one from one specific context. While the shared worker can be shared by multiple resources. So it can be executed in an iframe, it can be executed on a different domain, and can be called from different scripts. And that's the first conceptual difference between them. But also, they have different global scopes. So the global scope that we're familiar with is in the main thread, which is the window scope. So every time we go bubble all the way up to our global scope, we're actually getting the window object back. On a background thread or on a web worker, for a dedicated web worker, we get a dedicated worker global scope. And for the shared worker, you can guess it, it's the shared worker global scope. And though they're very similar, they have different capabilities based on the requirements that each one of them have. And now we get to the first little caveat that we need to acknowledge when working with web workers, is that if we want to write a task that is going to tap into that global scope, we need to be aware of where it's running, or we need at some point to make sure we are accessing the correct set of properties. And for that, JavaScript has a keyword for us, which is self. So self is always going to refer to the global scope. And then as long as you check if the property that you want to use exists, you can use self and you can write isomorphic code that would run in each and every single thread. And going forward, there's one more fundamental, the last fundamental difference between shared workers and dedicated workers, which is, unfortunately, shared workers have been removed from the WebKit engine. So there's no support on web workers for WebKit. And as far as I'm aware, it's not coming. So that's the last fundamental difference. And from now on, we're going to be talking about web workers, and they are those differences with a very small detail. They apply to both of them. The only exception is that shared workers need to have the port specified, but the APIs and the syntax are very similar. And now we're going to talk about some specificities of web workers. And the first one is the data. So data in a web worker is transferred. It's not cloned. And I really need to stress this out because the data being transferred means that it does not exist on both runtimes simultaneously. The data is copied from one thread to the other, and it's not shared at all. So once you send the data to the worker thread, we need to actually wait for it to come back. We cannot mutate it. And then this whole idea of best practices with immutable data and unidirectional data changes take a whole new level with multi-threading, because we cannot mutate the data that is going back and forth on the threads until we are sure that it's there. It's where on the thread we are expecting for it. And what happens is that the both threads communicate through the post message method. And the post message method is what states, like, basically a message is what we're talking about, the data being transferred. The message would imply this concept. And it's actually being done via a structured clone algorithm, which is just we don't need to dive too much into that. It's just so you know that it's how it's possible for both threads to interact. And another important thing about the data is that workers interact with the the data is copied through this algorithm, and the objects that are sent and received, they don't share the instance. They're perfect copies, but they don't have the same object instance, so you cannot do the equality check in this case. They're not going to be the same. And what happens is that this serialized this method post message is serializing the objects and deserializing upon arrival, and that's what the method is supposed to do for us. Another important thing is error handling. Because the threads exist in different runtimes, and because they exist in the different runtimes, a runtime error on a background thread inside a web worker is not going to block the main thread. And this can be seen as a feature, because if something happens in your thread, we don't block the UI. But that comes with a huge caveat that we need to listen to the error message, that's the event error that the worker is going to throw. Otherwise, our script is going to silently fail, and we are not going to get any kind of feedback to the user. So the way we do that is basically as we do with any kind of UI event. We just attach an event handler to it, and it's going to be and pass a function to it to handle with the data that's being received. And the most important thing we need to be aware of when talking about the web workers is how to keep our threads safe. And the first thing that is important to realize is that the specification did a really good job into isolating the DOM components that are not safe for the thread. So we cannot do some kinds of mutations on the main thread, because that would expose some security vulnerabilities on the main thread, which is the part where we connect to the user. Second of all, comes with the data restrictions that end up being imposed by that algorithm that we mentioned before, and the fact that we can only deal with serialized objects. So it's not every kind of data that we can send back and forth, and security is a main driving factor for that. And the last part is the fact that the background threads have their own execution context imposes an important issue that we all need to be aware of, which is that in most cases, or roughly all the cases where we are going to use a web worker, the CSP header from the main page or from the main thread is not inherited on the worker thread. This means that you may have done all your due diligence by setting the best set of directives to your CSPs, but this is not going to be forwarded to the worker.js unless you be explicit about it. So on the request for the worker.js file, it needs to be passed down the header of the content security policy with the correct set of directives. And I say that to 99% of the cases because there are two very edgy situations where this is not necessary, where the worker inherits the CSP from the main page. The first one being if the request that is serving that script, the origin of that request is a UID. UID, so a universally unique identifier. In that case, the worker file is going to inherit the CSP from the main page. And the other situation is once we deal with embedded workers. Embedded workers is basically an inline script that is added to your HTML with a different MIME type, and then you import that on your file. So I didn't even put an example there, but that's what these are the two ways. In most cases, you will want to have an external request, and that's how we do it. Last, and I'd say most importantly, we need to talk about the DOM. So let's review what we've talked about. First thing, web workers have a different runtime. They only deal with serialized objects. And I already mentioned a lot of thread unsafe DOM components are not allowed. So they're not available. And one can guess that the unsafe elements are the ones that are going to manipulate the DOM, because that's where we reach out to our users, basically. So it's not possible to do any DOM manipulation from the worker thread. You need to receive the objects and then do something about it. But yeah, you're all here to talk about React, and I've been rumbling about all this web workers and multi-threads and concepts and whatnot. So let's start. Let's get a React app on the screen. So first of all, I prepared a demo to bring out to you here, but I'm not going to run the demo because I'm running a very expensive task on this demo, and there's a chance that it freezes my browser. And if I drop out of my own talk, it's going to be embarrassing. So what I did was I filmed it and I recorded the screen. What's happening here is this React app that is running this very, very expensive task. And you can see as I click on the sync method of this task, the UI freezes completely. I'm clicking the boop, which is supposed to show something on that little screen, but it's completely frozen. Nothing else is happening. The button is even froze on the active state. And finally, when my task is done, the boops come in, and then I can continue to interact with. So if you have this expensive kind of task being run on your app, that's what's happening. Like, it just lands as a landslide on your interface. The user cannot do anything with it, and just need to wait it to be done. So our first gut impulse is, okay, that's obvious because you're doing a synchronous task. Let's do with a promise then, because that's what asynchronous code is all about, right? We want unblocking. But remember what we're talking about concurrently. This task is gigantic. So it means that whenever I click it, the engine very intelligently tries to run the task as fast as possible and then comes back to it and continue with the other task as it's finished. But it cannot, because the first task is gigantic, and you can basically hear the JavaScript squawking trying to jump from the thread, but it can't. And then finally it's done, and then you get the same behavior as a sync execution. So that's the main difference between what concurrent multi-thread is to what parallel multi-threads is. So let's see what happens with a web worker. And I'm just using the stopwatch, not to show you which one is faster, because they're basically the same engine running the same task, but to show you that there's no cuts in this footage. So as you can see, I clicked it, the same very expensive task is happening, but the UI is completely responsive. I can even show this loading state to my user. The user can still interact with stuff, and then finally, done. My big task is done, and the data is there for them. And you'll see that there are two buttons here. That's from later on, once you get to that demo yourself. I'm going to show you now two ways of instantiating this web worker. And let's get to it now. So again, the demo is just here. But please, if you're going to run it as I'm talking, just do it on a separate window, because I don't want everybody to disappear. Otherwise, the organizer are never going to call me back. So here's the code to our worker. It's going to be available on GitHub. I'm going to tweet about it. But first, let's have a look at it. What we're doing is using the self keyword, as you can see. And we're setting this event listener to this message event. Once we do that, we're running this callback that is getting the data from this event and passing to my big task. So the data in this case is whatever parameters I decided to pass it to it, and it's just shipping forward to my big task. And whenever that task comes back, it's going to send via post message to my main thread, and then it's going to give the data. And this is our first React code. It took us a little bit over 20 minutes to get to our first React code. And what we're doing here is just creating this button that's going to ship this task to our worker. So first of all, we're going to set the loading state to our button, and we're going to instantiate the new worker. Don't obsess too much about the URL constructor. That's something for our compiler. In my example, I'm using parcel2, but that would be the exact same thing for parcel1, for Webpack, and for basically any other compiler that I know of. So what we're doing is we're creating this URL for the compiler to know where to fetch our worker from, and we're passing the type module to it. And then once we're done, we're going to get our worker instance, and we're going to set a post message to it. And in this case, that's the parameter that my run big task method is taking, which is just a very big integer to make the task very, very expensive. And then our component needs to hear for that message event. So it's the message that's coming back from our worker. It's going to take the event, and then it's going to set the data, to create a set data method, use it to set a new state to our app. And that's where we get the feedback that the worker is done. But before we go on, let's look back at the line 13 over there. The post message method is just a platform method. It means in TypeScript lingo that it accepts an any. Basically anything that I pass down there, it's going to take it. The post message method is going to take it, and it's going to leave for the worker to figure it out. But my method, the method that I created, takes only integers. So, and there's no way in this component right now that I can tell you that. And I think we can do better. I grew too much accustomed to TypeScript to let this one pass. So we can achieve better developer experience with TypeScript. I think we can try. And the way we do that is with this little package called comlink. It's a package from the Google team. And the whole point is to use background threads like you're still in the main thread. So developer experience-wise, when you're writing your code, it feels that you're never left the main thread, but it behaves. It creates a multiple threads, and it works in parallel. How it works is with the proxy API, which is an API that's available since ES 2015, and by creating a remote procedure call to the post message. Okay. So here's how we instantiate our worker, the same worker, but now with comlink. What we're doing is create an object literal. That's going to be our worker. And we're going to create this prop that's run big task. And now it's a promise, noted. But internally, it didn't change that much. So it takes this async method. It awaits for my run big task. And then on line 10, I'm creating the type for my comlink worker from that object literal. And hold on to that thought. That's going to be coming handy later. And then I import the expose method from the comlink library, and I wrap my worker into that expose method. So the expose method is the one that's basically going to tell comlink, okay, let's do your proxy magic. Let's get me that post message RPC and get it ready. Back to my React app. Now I instantiate my worker just as the other time. But now I'm passing my worker instance to the wrap method for comlink, and the wrap method in TypeScript is what we call a generic. So I can pass that type that I created as a parameter, and then I know that my run big task is strongly typed. So then I can just call the set data, which is setting the state, and I can await for my run big task to happen. And that run big task is going to happen on the separate thread, on my worker thread. Just notice that that handler now became asynchronous though. That's the little one caveat. That's hope different in my app now. And that's about what I had for you today. But first, I just want to point out that web workers actually have more to do, more features for you to look at. First of all is the import scripts global function. That is important to reach for third-party resources from your worker thread, so you can actually import third-party scripts. Just be aware that if you pass a request that doesn't exist there, it's going to throw a network error, and then every code that is going to happen below that import script is not going to run. It's basically a runtime error as well. So every function declaration ends up being hoisted, just like in the main thread in JavaScript, but everything that's supposed to execute and parse afterwards is going to block. And I didn't mention it explicitly, but workers can actually instantiate and spawn new workers, and those are called subworkers. They behave just like regular workers. The only difference is that they are under another worker thread. So you can create as many workers from another worker as you want. And there are actually other kinds of workers and multi-threading, like, for example, service workers, those that we use to create progressive web apps. They are also a special kind of workers. And there's also the audio worklets, which aren't exactly workers. They are a little bit more limited, but they essentially work as multi-thread in parallel. And yeah, so going forward, if you're to take only one takeaway from this talk, what I want you to take is that getting out of the main thread is doable, and it's cheap for performance. It's cheap for your user experience and for your developer experience. So if you ever find your rendering performance being affected by some strong computation, or you need to run a big task in the client, I'm not saying you should, but if you need to, just don't feel shy of pulling a good old web worker to deliver a snappy user experience. There are no bottlenecks associated as long as you are aware. If you're supporting like new browsers, basically all these APIs are already supported. And yeah, that's about it. I hope you're not clinging to i11 anymore. If you are, there's some polyfills you can use, but there's nothing stopping you from using a web worker. And that's it. Thanks a lot for having me in New York. If you want to talk to me a little bit more, I'll be on the YouTube chat. I'll be on Twitter. Feel free to reach out to me with any questions you might have. I'm all ears. Thanks a lot.
Thank you very much, Atila. Very interesting talk. I have, I think, a question or two.
Okay.
So just by me, I guess. So I think like using workers essentially covers up with anything that has to do with heavy tasks on the front end. But do you think that like heavy tasks, like, because if I imagine something like this, I would let essentially the server handle that instead of having to do it in the front end.
Yeah.
But even if I go to the server and the server takes quite some time to respond back, I would still have a blocked UI, right? Or if I were to do it like in a normal way, so create a promise that essentially is a request to the server and wait for it to come back. So would I perhaps have, or I could have it in mind to use a worker to do, create a request for me?
You can do that. I think in this case, what's happening is if the server is taking long to get your request, then the UI is not going to be blocked, because for the UI, for the engine, it's basically, it fires the request and then it comes back to execute the other task. But if the payload that is coming from that request takes a long time to process, then I would say, yeah, definitely you can fire it from a worker. There's like one case that I think is very valuable. Like imagine you have like a very large data set and you're like in my job, I had to do that in the past, like handling a gigantic amount of a table with a lot of rows. And then at some point you want to reorder those, you want to make some change to all the elements in one of those rows. You can basically throw that data to a worker, let it run with it, and then it comes back. Or if you're running some kind of offline app or something like that, where you don't want to rely on an internet connection. Depends also on your user base. Sometimes we need to cater for an offline experience, and then you don't have the server right at hand. So that's what I try to say in the end of the talk. I'm not saying you should render like extremely heavy processing on the client side, but if you need to, use a web worker.
Nice. All right, so I guess that's exactly what you meant at the end. So keep that in mind, everyone.
Yeah, exactly.
So thanks for answering my question. Interesting stuff, of course. Thanks everyone for watching this talk, and I guess we'll have about 10 minutes as a break. Like Atila said, if you want to reach out to him, you can find him on Twitter. We have the name mentioned in the talk and also in the description of the video. And I guess we'll take, like I said, a 10-minute break and see you in the next talk with Milica. Thanks everyone for joining us. Thanks Atila for the talk. Thanks for sharing this very valuable stuff. And we'll see you all in about 10 minutes.
Okay. See you later. Bye.
Bye-bye.